Electric, our topic is electric field intensity in an electric field due to dipole. So for this purpose, we have to draw a figure of dipole like this. It is a dipole, and as you know that dipole will make with the help of minus q point charge and plus q point charge, and these charge will surely in equal in magnitude but opposite in nature, and the middle point of this dipole is O, and this point is A, and this point you may say B. The distance between OA and OB you may say written as L, and this is also L. And we have to find electric field intensity on the axial line. Axial line means along this line AB. So we have to find another point on this point like this. So this point you may assume as point P, and this point P, a test charge is held, that is called Q naught. So the distance this charge from the center is R. But as you know that it is our dipole, and in individual case Q naught will be affected by these two charges separately, and at this point two electric field intensity will work simultaneously due to the minus q and plus q. So the electric field intensity due to this plus q charge will be this side, and you may name this as E1, and the electric field intensity minus q at this point will be left side, and you may write it as E2, vector E2. And the distance of P from A and B separately will be R minus L, and the distance between A and P will be R plus L. So now we have to find the separately E1 and E2 at the point P. So in magnitude E1 and E2 different because the distance this charge from these two charges are different. So because R minus L is less than R plus L, so therefore magnitude of E2 is less than magnitude of E1. So now for this we have to find net intensity at point P. So the net intensity will be E is equal to E1 minus E2. Now put the formula of intensities of these two. So the formula will be 1 upon 4 pi epsilon naught and Q upon R minus L square, uh, whole square of R minus L. Similarly, intensity of E2 will be 1 upon 4 pi epsilon naught and Q upon R plus L. So we have to take in a common. So common will be 1 upon 4 pi epsilon naught, and you can write here Q. So in bracket we have find 1 upon whole square of r minus L minus 1 upon whole square of r plus L. Now, you have to solve this bracket first. So, q upon 4 pi epsilon naught, and so the LCM will be whole square of r minus L and whole square of r plus L. So where we get, here we get whole square of r plus L minus whole square of r minus L. Q upon 4 pi epsilon naught. So here we get, because both the length have a square, so you can write it as r minus L, r plus L, and on the curly bracket you put write 2 power of 2, and open these two squares. So here we get r square plus L square minus plus 2 RL minus r square plus L square minus 2 RL. So now q upon 4 pi epsilon naught r square plus L square plus 2 RL minus r square minus L square plus 2 RL, and here we get r square minus L square, and either whole square, here whole square. So r square plus r square minus L square will be cancelled. Similarly, plus L square and minus L square will also be cancelled, and we have leave only this in this bracket will be 4 RL and r square minus L square. So whole square of r square minus L square. Again, q upon 4 pi epsilon naught and 4 RL upon r whole square of r square. And here we leave L square because uh, r square is very greater than with respect to L. So L square can be leave. So now q upon 4 pi epsilon naught 4 pi RL r to the power 4. So here we get power 3. Now 1 upon 4 pi epsilon naught 4 QL upon R cube. And now, as you know that P is equal to 2QL, so we get 2 from 4, and QL will also exist. So we will find here 4 pi epsilon naught and 2P upon R cube. So here is our electric field intensity due to electrical dipole at this point P. I hope you can understand it well. We will meet again in the next video. Till then, goodbye.